Okay, guys, I think we can start. Welcome everyone for another webinar from Cloudbeat. As always, we try to bring you industry experts, advice, best practices. And today we are going to have with us Ronak, QA Director of Forbes magazine, who is going to share with you his own experience and his own journey and his team journey from moving from traditional QA to continuous testing and to modern QA process. You will hear all the bits and bytes. So many of us and many organizations are, especially now in COVID time, are in transformation, moving from classical development model to more digital more digital facing. Is it more exposing your services to a digital world, moving away from is it moving away from monolith to microservice and so on. And of course it's today's talk will be very interesting for either you are a QA manager, a developer, a tester, to understand how you take huge digital assets such as Forbes magazine and how you transform it through the process and take it really further to the next level, QA and continuous testing. In terms of rule of engagement, so you have guys in your Zoom toolbar, you have Q&A section. So we will leave enough time at the end of the talk to ask any questions you like. But if you have any question particular to a slide Ronak will show or to anything related to more understanding, then feel free just to drop your question in Q&A section or in the chat. I will be watching chat and Q&A section. If it's relevant to a particular slide, I will ask it to Ronak. If not, I will leave it to the end of the session, and we can then just just have an open conversation. So feel free to make this session more interactable, and also just get max out of it. Ronak, I will pass the session to you. Let me just stop sharing my screen.
Great, thank you, Nick. Let me share my screen.
Yeah, I made you host.
Cool, thank you.
Yeah.
Awesome. Can you guys see my screen now?
Yeah, we can.
Awesome. Thank you, Nick. Thank you, Nick, for the introduction, and thank you everyone for joining and giving us your most precious commodity of yours, which is time. And I do see some familiar names in the audience, so nice to meet you guys as well, which we haven't spoken in a long time, but thanks for joining this call as well. So I will start explaining our journey from where we started, where we are right now, and what we did in our whole transformation journey, and what we did really worked for us, and maybe something you can take out of this journey and implement in your work as well as in your organization to grow. And also, as Nick mentioned, if you have any questions, feel free to ask in the Q&A section, and Nick can ask me question there and there itself. So let's make it as interactive as possible so you can get the most out of it, and then it's well worth of your time to spend like a Wednesday afternoon with us. Thank you. So I'll start by giving a brief introduction about myself. Well, how I started my journey as a QA. I am currently a QA director at Forbes or Forbes.com. Lead the quality assurance effort here. I started my journey as a QA intern back in my grad school. Then I migrated myself into a manual test engineer, which I worked for a couple of 3 years, then and transitioned to an automation engineer, to a senior engineer, to a lead, to a manager, to a director. So I've been in QA space throughout my career, and I've learned almost most of the pain points as well as the glory point you face in your QA journey. So I have experienced that. I have worked in different domain and industry as well, where I started in working in the media space, then worked in a software as a service and HR talent acquisition software, then worked into an ed tech, which is really high in New York City, which you have a lot of advertising and technical, technical and advertising media space, then worked a bit in finance as a consultant, and then now again back into the media publishing group. So I'm full 360 where I started and came back again and working at Forbes from since 2019 January. Uh, I am very passionate about software testing, and you can really see from my slides as well as from how passionate I am about software testing. And I can say the passion is so much that I love this field. I love this domain, what we do, and really help myself to drive every day in and day out. Which brings me to Forbes. So you must have heard about Forbes.com, or must have at least been to our website once in your lifetime. We are around 108 years old company. We are leaders in business, finance, and entrepreneurship wise. We are very popular as a magazine, as a brand, which you can see a cover page here. But since we are in the digital world, the paper subscription of a magazine is kind of getting obsolete, and which has taken over to our website, which is Forbes.com. And my team, and in this pandemic world, we have been exposing like a record breaking traffic on our site. So if you see that from the slides down here, we have around 185 million monthly subscribers on our site, who visits on our site. And on the month of August, we had around 118 million subscribers monthly. So US population is around 330 million. So around 35 to 40% of US population has at least visited Forbes.com in month of August. And this has grown since September, July as well. And we have around 300 to 400 contributors across the globe, which writes for Forbes.com. So we did publish around 300 articles on Forbes. And our primary source of revenue, or major source of revenue, is advertising. We recently launched subscription service, but our major source of revenue is advertisement. So with this much traffic, with this many user base on our site, the site upkeep time is really important for us, because if the site is down, we lose revenue, we lose our trust in our audience, the quality of assurance. So quality assurance group becomes equally important. In Q3 and Q4 or Q2 and Q3 this year, our site uptime was 99.99, and which was testament to the whole engineering group as well as our QA initiatives, which has made us this far progress. So since you learned that how QA and quality assurance is really important, and I don't need to explain to this group, but for Forbes, it's equally important because we have this much high record number of traffic, and we need to perform our site optimally and introduce new features as well. So the QA group is really important. And we, as a quality assurance group at Forbes, are a point person quality check in the team. We are responsible for testing our front end of our site, which is Forbes.com. We are also responsible to test our backend. When I say backend, it's our content management system. So like we recently migrated from WordPress, custom WordPress, which we used to support for around 8 to 9 years. We built a homegrown custom CMS system, which we call it as Bertie. Bertie is a founder who was a Forbes founder who started Forbes magazine early, like 100 years ago. So we named our CMS system as Bertie, and it is very amazing UX, or I would say the feedback which we got from our users who is using our CMS has been amazing, and we have been supporting testing that as well. We also have some of the data products. For example, a lot of our third-party providers consume data from Forbes.com, like Bloomberg takes our feeds and then publish into that platform, versus there are other providers as well we use our data products. So we test those features as well. And we work really closely with our developers. And that's a testament in our team as well, that we are equal partners in our code quality checks. Our hiring process for a QA engineer versus a developer is exactly the same. Our code review process is exactly the same, which QA checks. All our automation check PRs are reviewed by developers versus the dev codes are reviewed by the QAs. So we work very hand in hand. There is no, in our engineering organization, there is no world of second-class citizen of QA or a dev. We are equal in all this aspect. We just work on the different code base. But apart from that, all other standards are exactly the same. And that has helped really well for us to grow as a quality assurance organization. I'll go to the next slide. Oops, I went all the way to the last. Sorry about that. the wrong button. All right. So sorry. So let me begin explaining the objectives of this talk so that we are clear how I'm going to explain my whole journey. So starting from objectives, so I'm going to go over where we were beginning Q1 2019, where we started this journey of our transformation as a QA cycle. How was the release process used to look like? How we used to test features? How was our approval cycle for getting a feature out? And what was our average defect or whatever defect leakage percentage was, or how was our release quality was. Then I'm going to explain what are the processes and that we implemented, what are the tools we used in this journey, and how it has helped us to go where we are now. So what's our current software development life cycle is, what is our approval process, what is our release cycle, and then we can say that how has it improved in our quality journey. And that can help you to understand that what we can take away from our journey or our change which we implemented to help you grow your career or your organization as well. And I might go fast, but if you have any questions, feel free to ask in the Q&A so that we can make it more interactive as well. Cool. I'll breathe for a second with the water. I'm going to start explaining what our release cycle used to look like. So 2019 beginning, when I joined Forbes, a release cycle used to be agile, sprint based, but it still was very waterfallish. And I explained how we used to do. So we used to do a bi-weekly releases. We used to do release 2 times a week, Tuesdays and Thursdays. But our general release process began on Friday, where a dev will merge all the tickets which are completed work into a release branch. We used to nominate a merge master every week from our dev team, and that person was responsible to deploy the release branch into a staging environment. Staging environment is where our stakeholders, which will approve all the changes which will go on. Then the QA will perform regression against the staging environment, run the automated test locally on their computer against the staging environment, and we sign off on all the changes. And when I say stakeholder approve the changes, our stakeholders for all our features we release are our revenue team, our product, our editors, or the edit team. So they have the huge stake in what features we release, because that all those features or all the changes which we make which impacted their day to day or how they work. So before we release any of our changes, we need their approval so that they are on the same page and our engineering team don't impact that. So that was really crucial phase for us. So they used to approve all our changes on Monday, and later half of the Mondays we do manual regression. Manual team used to go ahead. We used to have around 7 manual testers who used to regress our site and all the different features, and an automated test used to run all the tests locally, and we used to update our Confluence sheet with all the passing and failing tests, and we release all those features on Tuesdays. So merge master is the one now then merge the release branch into a main or a master branch, and then deploys to production. And then the QA team starts doing the manual regression on production again, and then the whole cycle repeats again on Wednesday, which for the Thursday releases. So this whole rigorous process used to happen Tuesdays and Thursdays, which you follow this, and QA team is always on the edge of rushing to test the feature once they have approval from stakeholders, QA all those things manually, and then release it. And you can imagine there are a lot of flaws in this process, and which is not scalable at all. You have to it's very time consuming, and which is very evident. And we used to spend around 20 hours of regression time per environment. So 20 hours for staging, 20 hours for production every week. So 40 hours we used to spend per one release on an average. And that was spanning across manual team and automation team itself. So this was not scalable. We were able to release bigger features, but this wasn't working really well where we wanted to be. So what we really implemented to make it change. So we broke it down into multiple phases. The first thing which we did, when again I will mostly talk about processes as well as technology or the QA changes as we go along, but I'll start with the first changes, which is a stakeholder alignment. This was really important for us because the problem we getting the stakeholder approvals later in the cycle was that if they found any defects or if they found any change which they don't like, we had to pull it out of the release branch or do a patch or do a hot fix for that change and then release it. So we'll scramble around in really short of time, the devs, QA, and everyone used to involve. So we used to start getting their buy-in early in the cycle, so we don't get the last minute delay. So I'll go into details of each of those items later on, that what we actually did to get stakeholders alignment sooner. But I'm on a very high level, I'm going to explain the key steps which we did. The next thing we did was implemented more test-driven development, where when I say test-driven development, we started adding more tests at a lower level, so that if we find any issues, we can catch it before even it goes into the release branch or the integration branch. So we can find things on the feature branch itself. And this approach actually make it more uh, developer developers started focusing on quality way more, because if they added a new JS file, for example, front end, if they don't have a dedicated spec file, our linters will fail itself, or unit test will start failing. So if they need to have a unit test added, the code review will not be won't pass. So all those steps we implemented so that we can get faster feedback, and the devs became an equal partner in maintaining qualities, just not fall in the QA team to write an good end-to-end test. So we started adding more tests at the lower level and adding lesser tests at the higher level. We migrated our infrastructure to cloud, which will make us really nimble and fast, so that we can spin up our test environment really fast and scale down our test environment as we needed. So that made, before we used to be in a traditional server, we still had an ability to do spin up our test environment, but they were not as scalable, which we have flexibility now in the cloud infrastructure, because we can spend pennies and our environment is up. So this was a huge cost saving, as well as huge beneficial for the team as well. So we implemented a cloud infrastructure. We started having individual sandboxes, which is where for each feature branch we'll have an individual environment to test that feature branch. So we don't need to check out the code locally, build that local version of it, and then test it. We will have sandboxes on that branch itself on the cloud as soon as the branch is up, or the PR is up, or the pull request is up. So we can run our individual feature test on that branch or the sandboxes. The next one which we did was we started uh, having more automation integration tests as well, but we started following this. We always have it, but we didn't have a way to run it on every single change, which is what we changed, which is very standard in the industry who wants to move to continuous testing, where you add more automation tests and which run it. But these are the tests which gives you the most confidence that your application is working correctly. So your automated test or your end-to-end test, if they are passing, you feel that your application is working, because you are trying to mimic a user scenario. Versus if you have thousands of unit tests, you still don't have confidence enough that what will happen if all the pieces fit together. So adding integration test and end-to-end test really gave us that confidence, but our number was still lower what we want to write automation and integration test for. And the last was a fluid release cycle. So we never had, now we don't have a release date. Like we only release on Tuesdays and Thursdays. Now we release every single day of the week. We started releasing that you can, as soon as the feature is ready, all the checks are passing, we release the feature out. So those are the main key 6 areas which we implemented to make us more closer to continuous testing. And I'll go into details of each of them in no particular order. Mostly I will focus mostly specific to what QA is, and spend very less time on process uh, or test-driven development approach. But I'll focus mostly on what QA team did and how people who are in the quality assurance group will be beneficial. So the first thing I'll still say that the cloud infrastructure was a key catalyst for us to move towards move towards the continuous testing, because that allowed us to spin up our test environment on the fly. So we migrated, I think in April last year, we migrated our Forbes.com complete infrastructure from a server into a Google Cloud. So we are heavy on GCP now, and that allowed us to have a very scalable Kubernetes environment for our test as well, where we can spin up our test branches or on the fly. So we built a custom app which will allow us to do a certain action based on a predetermined action. So for example, if you see in the screenshot here, if someone adds a label on our pull request, say a dev box or a prod dev box, it will kick off a Jenkins job, and that job will deploy that branch into an environment, and then reply back as a comment saying that this environment is ready for you to check. So manual QA who is exploratory testing that feature, they can go to this URL and check that and the change is working correctly or not. So we don't need to check out the box locally. So that actually really helped us to spin up our test environment really fast. What this also helped is our stakeholder approvals don't have to wait until it's on release branch. They can start approving on this feature itself. You don't have to wait for someone to deploy the change on a staging environment. There is no staging environment now. All these are individual sandboxes which is very configurable, and you can figure out if you need like a prod version of the database or the staging version of the database, and you can generate it by just adding a label on the pull request. So those automation really helped us to move forward in the process. And if that feature is tested, all the developer or a QA has to do is that remove this label, and then that will be destroy the dev boxes and make it, and that resource is available for creating any other dev box for any other future PR. And this is just an example of our front end of our site. We did very similar for our back end as well, or for our API as well. We used to create test environment on the fly following very similar procedure. So that makes us really help to do our testing better. Cool. The next step which we did was adding a different checks before a pull request gets merged. So I mentioned before that we don't have a dedicated a release date. So we can release whenever something is ready. So for us to release certain things, we used to have like 15 checks needs to pass in order to PR to be ready. The first thing we check, we do some static analysis on our test. We run some linters on our, and this is example of our front end again. And we have very similar for our API and backend services, or some microservices as well. But for our front end, it runs our unit test, it runs our linters, it runs our AMP validation checks, which is we check that our pages are AMP, and AMP is accelerated AMP pages. For you guys who are familiar with it, we runs against a validator which AMP project is giving us, and make sure that HTML is structured correctly. We run our functional test, which we use Cypress and Protractor, which I'll go next in the next slide. We run some code climate check. We'll code climate checks that run some cyclomatic complexities and all those tests and make sure they are correct. And yeah, and if all those checks passes, we merge our branch. If any of those fails, it will block us for merging it. And as soon as we merge it, and explain it at the end how our release cycle is. But as soon as things gets merged, a release build is getting kicked off, and it will deploy things to Canary and to production. So this will help us to deploy things when they are ready, and also do a check in a proper way. All our tests runs in mostly parallel. So for releasing certain things, or running all the checks takes around 30 minutes on approximately. And we do retry on failure. So let's say 30 to 45 minutes are a ballpark number to release a particular feature branch to production, or to run all the different checks. So we started a lot of different checks to make sure that we test it in an automated way, and we test it continuously. So every commit or every change to that pull request runs this checks. So it doesn't just run at the end, but whenever you may push a commit, it will just run all the check against. And so the developers get the feedback immediately. If something fails, he fixes it, pushes the next commit itself. So it's very iterative, faster feedback is what we went for. And explain a little bit about my team as well and the stack we use. I explained what are the stack we use. So we have a fairly small team based on the thing which we covered, because we work very closely with the devs as well. So devs also help us out to write some automation tests as well as review our tests. So our team is fairly small. We have around 4 manual testers and several automation engineers. And manual testers are the team who are responsible to do more exploratory tests, who writes our test cases, who reviews the new feature going on, and used to do regression. Now they are solely focusing on doing more manual exploratory testing, and regression is mostly done by our automated checks. The stack which we use is JavaScript, which we use right to Protractor and Cypress. I'll go into details what we do for each Protractor and Cypress test. Python for our API integration tests. Or newer microservices or services we are building, we use Python for that. And we are writing an integration test in using Python. We use Locust for a load test, which is again a Python library which allows us to write a load testing as a code. We are old legacy Java API. We use Kotlin to write our integration test. We use Browser Stack for our cross-browser testing. For geolocation testing, we use Wonder Proxy, which allows us to run our test against the different IP addresses. So one of the key things which we did, that we are language agnostic as a team. If we write tests which works the best for the whole group, as well as which has a better tools to make the job done. So our team, if you can see from the examples here, that write test in Kotlin, Python, JavaScript, and basically wherever we have a more knowledge base within the group, so devs can contribute as well. You don't want them to have an extra burden of, if the devs are only knows Java. We don't want to write Java test in Java. We can pick something better because we are starting from fresh. So we pick Kotlin, which is still Java, easier to learn underneath it, and it's a better DSL to write the test on. So our choice of stack and languages varies based on the need as well as what the capability of our team is, if it makes sense. The next one is, then I'll start going into each individual tools and how we write the test and what we do that. So Protractor was the one which we inherited from where the team started writing Protractor tests like 6 months earlier before I joined. We used to have our front end articles are used to be an Angular app. So Protractor was fitting really well needed for that sort, but we soon migrated our Angular app into our more vanilla JS framework, which we built on our own. It follows, it is very opinionated framework, so I won't go into detail what exactly it is, but we started writing just vanilla JS to and migrated from Angular to that, so our front end. So we still had written almost 30 to 40% of our test in Protractor, which we don't want to spend, and those tests were working fairly well. So we don't want to migrate to the existing one, even though there are better tools available than Protractor to write the test for. So we kept that. And we only started doing ads and tracking specific tests using Protractor. We don't test any functionality on Protractor because Selenium has its own weirdness, how it interacts with certain elements and how to weight. So if you don't, and it's nothing wrong with the Selenium, it's wrong with how the test is written or how you interact with the page. And there are a lot of the nuances which makes a Selenium test less flakier. So we started doing only our ads and tracking test using Protractor. And when I say ads and tracking test is, as I mentioned before, that Forbes is revenue is ads. So we want to make sure that our ads are loading 100% correctly. All our tracking values, we are tracking different ads to serve on different page are working correctly. So we started testing all those parameters which shows up on the page correctly. And all Protractor test does, it loads a page or a particular URL, and it runs some custom JavaScript which checks for certain values on it. We don't really do very Selenium heavy work on Protractor right now. All we use it is for load a page, check certain things, it works correctly, pass the test. So that allows us, because it's very lighter Selenium heavy, we can run many tests in parallel, and they're very less flaky because we don't have to wait for anything else to happen. We run our code asynchronously and it just works really well. And how we run in parallel is we broke down our test into different suites, and each suite is a different config file. So if you've seen from the screenshot here, we have a multiple config files here, which is, you can see is protractor ccpa.com, protractor desktop.com, GDPR, geolocation, mobile. So each config file has a different config settings for a particular suite. And we can run based on our current resources in our workspace on Jenkins, as well as how much Selenium can run it. We can run two tests in parallel optimally without making our test flakier, without putting too much load on our VM. So we run like two tests in parallel, and we are running 4 suites. So you can say we run closely around 8 tests in parallel across different combinations, which across mobile, desktop article, and desktop mobile. So as I mentioned, as you see in the screenshot in the previous check, each of those suites are a check in our PR, and they run 8 checks in parallel specific to Protractor. And yeah, and that's how we do it. And then this is just an example of a config file. And you also know, and being in QA world, that the Selenium tests are super flakier. So we want to rerun a failed test. And to do that, we did a little bit different than what comes out of the box for Selenium, in which we have to use some plugins to do that. But what we do is we have our own custom Mocha reporter, which will parses the output of each test, whether it passes or fail. We feed that output into a spec file of the spec file into this config file. So if you see here in the config file, we put that value saying this spec file failed, rerun again. And we rerun them 5 times before failing a job. So if one of the tests in a spec file failed, we run them again before failing the whole job, so that we have enough confidence that there's no flake here. If the test fails once, we run it again, make sure it fails again, it runs again, make sure it fails again, so that we have enough confidence that our test is failing for a legit reason, because there is very likely chances that it will flake out 5 times. If it flakes still than 5 times, then it's a different problem. But generally, we try to make sure our tests are passing most of the time. And the last thing I mentioned is we use Protractor for testing our geolocation specific tests. We use Wonder Proxy for that. So for our CCPA or GDPR compliances, so if someone loads our site on in California IP or someone in Europe, they will have some CCP or GDPR compliance pop-up shows up, and then certain targeted specific to that IP ads also loads on that. So we use Wonder Proxy for that, and we run, and we also have we already have Protractor, so it's really easy to write some tests for that. So we use Protractor for running some of our legacy tests as well as the newer ads and tracking specific tests we are adding. We migrated to Cypress a little bit around May last year. The reason behind is that it had a great built-in features, which with Selenium, which can do very similar things on Selenium, but you do extra work, but this Cypress just comes with it. So been using Cypress for a long time, around 2 years. I've been using it in different places. So I moved over that tool, which worked really well. It has a lot of good features which made our life a lot of easier. So makes us writing our functional test really simpler in Cypress. We mock a lot of requests which we make to third party. So for example, if you make a request to third party, we don't have to wait on if the request is wrong or not. We can mock it using the built-in mocking feature. You can listen to the request, you change the response, and then feed it to your front end. So you can expect exactly what you get on the front end. So that is huge for testing just front end of our application. The wait feature is really good in Cypress as well, where you can actually wait for a request to finish within the browser, and then you can check certain things shows up on the page. So that feature really helped us to write our test because Cypress runs inside the browser. It has more control over than what Selenium has. And I'm not opposite what Selenium was, but the architecture of both the tools are different. And Cypress has this advantage, which will make the test less flakier. And then it also has some features where you can run your API or REST API test in Cypress. So that will give us less time for the team to know a new tool. It's easy transition phase. So we use Cypress for some of our smaller node-based API services as well. We use Cypress for that. Cypress has a parallel execution as well, but we don't use the dashboard feature of Cypress because it's a paid version. We make it working by running a different npm script, and each npm script we have which run a different suite in Cypress. So right now we run 5 suites in parallel on a headless Chrome on the same Jenkins workspace, and it's very lighter compared to what Selenium is. So we're able to run 5 suites in a parallel on exactly the same resource which we have for Selenium. So we run around 13 tests in parallel. If you can see from our previous, if you add 8 from Protractor, 5 from Cypress, we run those in parallel for each of our PR checks. And Cypress has a built-in feature for retry, so we don't have to do any custom to retrying our flakiness. It retries 3 times. Most of the time, the second and third time, we get it the test passing. And the other thing which Cypress dashboard has, which we also built our own, which all the failed tests take the screenshot. But then if you want to see those failures, you have to you have to subscribe to the dashboard services to see the recording, which we eliminated by capturing the screenshot and uploading the screenshot in the GCP bucket. So if you see in our Jenkins script here that we are copying the screenshot into a bucket, which we have on our Google Cloud. And when someone debugs a failure, all they have to go is go to the GCP bucket, find the job where the test was failing, and then look for the failure. So this was really helped us to write the test better, the test runs more reliably, and then we picked what's best for the need. So we didn't eliminate Protractor because that was doing a good job for us, but we picked for the newer tool, we picked a better tool, which made our life much better. Cool. So next set of tests we do was integration test, as I mentioned before, because we do different types of tests, and we write a simple black box REST API test. So we don't care how the API service is built, either it's built using the mock MVC or it's using a node. We write our test, you making a request, make sure the response comes back. So our API is built in Java, and I forgot the whole framework which we built our data test on, but we use Kotlin to write our test for. We use OKHTTP3 as a REST client to make a request, and we use Kotlin test as a testing library to do all the assertion. And for Python services, we start writing a test using the black box API requesters. And as I mentioned before, we have so much record number of traffic. We need to make sure that our application is scalable enough. So we do load test a lot for our backend services, not more of our front end. So we check all our new endpoints we introduce or the new service we build. We run our API test, and we use Locust for that. Low-code is really good because you can mimic user scenarios. You can spawn user on the fly, and on top of it, it can run in a distributed and scalable way. So we have a cluster up which has a locust install, and you can spin up as many nodes as you want. So you can potentially mimic infinite number of traffic or users on the side instead than waiting for a JMeter and worrying about an XML files. You can just write a Python code, and that will scale up users and runs your load test. And it is very cost effective as well, because we only spin up the cluster to run a load test when we need it, and we shut it down when we don't really need to use it. So whenever there is a big change where we want to test an impact of a change, we spin up our cluster to do the load test. If you want to generate more users, we spin up more nodes and run the test and observe the results. So that worked out really well for us for our newer services or microservices we have launched. And as usual, Jenkins is our source of truth for all the work. The reason we use Jenkins is that our internal team, DevOps, QA, or the developers have a good knowledge base for using Jenkins. Each our Jenkins has a containerized workspaces. So each worker or each job actually spins up a new container and runs the test. Our resources are pretty heavy on the containers as well, because on the cloud, we have around 16 gigs memory for running our end-to-end test itself. And that allows us to run a lot of tests, like 8 tests in parallel together. We use preemptible VMs, which is also very cost effective as well. And we only need to, so we don't pay much. We get whatever is available when you spin up a container and run the test. We run test, and this is another cool feature which we have implemented, is that we can rerun the test by adding a comments on GitHub. So for example, if the PR checks is running, one of the test fails, we want to rerun them again. We don't have to go to Jenkins and run it. We can just add a comment on GitHub with the specific terms, and that will kick off a Jenkins job. So in this example, if you can, I don't know if it's clear enough, you can see, but here we are parsing the comments which people have. Let me start the pointer so you can see. Okay, so here we are parsing some comments from the GitHub and making a REST call to the Jenkins API and trigger a job. And once it triggers the job, it will record back the result back into the GitHub. So that allows the efficiency of the team of not going from one platform to the other, and you can just run the test from Jenkins itself. So I mentioned that we run tests, we do this, that, but how many tests we run, how we run it. So this is the data of just our front end of our site. So we have around 8,000 tests for our front end, for which runs on AMP, desktop, and mobile. So 8K tests in total, which runs in different capacity for all the different pages. We have tracking specific tests, which we use for Protractor, which run desktop, mobile, and AMP pages. And those two in total takes around 30 minutes to run. For our functional test, we have around 1,200 tests we wrote for Cypress. It also takes 30 minutes to run all those tests together. And our benchmark is around 30 minutes. We don't want to add more tests, which takes it longer. So if we add more tests, we increase how much tests we run in parallel, or reduce the tests which are absolute or doesn't make sense for us to keep it. So we run around 1,200 tests in parallel for functional testing as well. So our checks, as I mentioned before, takes around 30 to 40 minutes to run all the tests together. And once all those tests passes, we deploy this thing to production. So I explained most of the things about what we did from a testing specific perspective, as well as the infrastructure perspective. But the other thing was really important was the stakeholder alignment, which you must have guessed that now, since we have individual dev boxes, they started approving tickets there itself, which will really saved so much of their time that don't have to worry about a staging environment to be ready to approve the changes. The next thing we did was we started doing some integration and wrote our own custom integration between Jira and GitHub. So for example, if a dev opens a pull request, the associated Jira tickets is moved automatically to code review. Or if they merge a branch, the Jira status changes to close automatically. So devs hate going to Jira, and they don't have to manage 2 different places. They can do everything from GitHub. All they have to worry about is they don't even have to mark the ticket in progress. As soon as the branch is open, the ticket is marked, or branch is pushed to the remote. GitHub, we change the status of Jira to in progress, And then we change as soon as the PR is open, we change it to code review, and then when it's done, it's closed. And we made some workflow improvements as well, where we started some automated process of sending emails notification to stakeholders for approvals. We use some Jira plugins called timing status or Jira approval, which help us to do some reporting and also remind our stakeholders if they have not approved a ticket until certain time. So timing status gives us report that how much time a ticket is in one status. So if the ticket is in stakeholder approval status for more than 2 days, we send them reminder emails that can you check it again? And this all happens automatically. So stakeholder approves it, and as soon as they approve it, it goes to a QA review, which a manual QA will check the feature is working correctly. If the automated test is already done, we just push the button, it goes to production. So this is a huge time saver, and it took a while because we need to get a lot of people on board where they are comfortable checking the whole thing as a whole versus one individual ticket. But we gain confidence showing our release cycle, showing us efficiency of how fast we can release and how our things are working in production. And then last thing was the fluid releases. So fluid release is something where we don't have individual branches. We releases as things are ready. We don't have a fixed time. We started now truly exploiting or using an exploratory testing phase where we use a tester's imagination to test it rather than following a step-by-step test cases. And this has made a job of a manual testers really fun as well than just testing like step-by-step instructions on a test cases. And we don't have a set release date. So that has helped to do a whole flow together and release things. So now what our release cycle looks like now in 2013. So as I mentioned that as soon as the feature branch get merged to master or a main branch, we trigger a Jenkins job, which will deploy a change to Canary. We run each end-to-end test on the Canary environment. If end-to-end test fails, we roll back to the previously successful version. If it passes, we deploy the change to production. So when I say Canary, Canary is our smaller version of our production environment, which only gets about 10% of our production traffic. So we deploy a new change to Canary. We run our test, make sure all the tests are passing. If they passes, then we deploy to production. So we can still roll back. We start tagging our releases per the last commit messages as well. So you might say that what if someone merged things by accident? So if someone merges something by accident, it has to pass through all the checks first, as well as in order to deploy something to production, we want to have a commit with a specific keyword in it. So if we need a keyword, we put a keyword called release. If the dev wants to merge something, they commit to the branch which is going to merge with a keyword called release. Once it has a keyword called release and we merge into main, it will deploy the Canary, then end-to-end gets triggered and then get deployed to production. So that way it has a fail-safe check, and then we start tagging our releases for each commit as well. So we squash and merge our commit into one commit hash, so we know that what was the last successful build. So when we roll back, we need to know that which commit hash to roll back to. And all this process is we constantly notify in Slack channel. So we have a dedicated build Slack channel which posts a message that when each of the phase is passed. So when it deploys to Canary, it notifies it. When it successfully deploys, it notifies in Slack channel. When it's time to roll back, it notifies in Slack channel. So everyone who is part of the channel knows that things are happening. And we just don't notify one channel. So for example, QA channel has get notification for anything which goes out to production. We have a build chat with only post notification for anything which is deployed to production versus or on Canary. And QA gets notification when anything is deploys to a test staging environment or any other environment. So Slack notification, Slack is our go-to thing, and which has helped to reduce a lot of manual emails and back and forth where, oh, I'm deploying this. That doesn't happen anymore. Everything happens through automated emails. And what are the key takeaways from this journey? Since I didn't get any questions, I believe, I'll just go here and go in really high ways that one key takeaway what we have learned from this is don't work in a siloed environment. Don't, as a QA group, always be an equal partner with a dev or an operation or a DevOps person to get your job done. So that was a one key takeaway for myself as well as our team as well, that when we worked on this, all our work was, whatever steps I mentioned, this is not all done just by QA. devs helped us out, operation helped us out. So we used to create tickets in the operation board saying that we need this to happen. Who can help us out? Or we have done this much work. Can someone help me out to unblock this feature? So we worked together, and that made us really achieve a great results. And then we are equally proud about adding all this automation in the whole workflow. The next one was writing the test code. So this is a notion when someone writes a QA code where the test code quality is not as good enough, then it becomes really messy to manage, and then no one wants to even touch it. For example, if your automation code is really bad enough, you give to dev to write a pull request, they're like, what is this mess? I don't even want to touch it. So if your test code is good enough as a production code, everyone would like to contribute towards it, or would like to improve on it or learn from it. So right cleaning test code is really important. And also follow some good practices when you write your test. So one of the cool thing was we started only testing one condition for our test. Do not do more than one assertion in a test. When you write a test, have like a given whens and thens, or a setup, what you want to test and what the expected values. If you follow those scenarios, that will help us to run our test in parallel without getting into so that allows you to, we don't have any state in your test, so you can run your test in parallel. It runs it runs less flakier, because you've seen that we are doing a lot of retries in our test, and only way for the retry to work correctly is that your test should not have any state. If your test will have a state depends on a previous state, you have to retry two tests together. So in our case, we only retry that particular test because that test is independent, it can rerun by itself. And also do value stream analysis of what to automate and when to automate or don't automate. I think that is really important as well, where when we get a story or thing to work on, people jump around and start automating it. There's no real need for it. If the feature is very short-lived and it's not going to add value in the longer run, or it's not going to save you any time, do not automate it. We don't automate cross-browser testing. And there's a reason for that, because our test works on Chrome, it works reliably. We don't have time and energy to spend to make it work on Firefox or Safari or some other browser. So we solely focus on running our test on Chrome. If it works well, it's good. If it doesn't work well, we do weekly exploratory checks on cross browsers, and our team checks for those. And we find issues, we fix it, or we figure out if there is a major thing. But for so far, if it works on Chrome, it works on 80% of other browsers, because all the newer tools which we use, which all the libraries we use are mostly cross browsers. And then we code, our developers write test or write application which is scalable and which works on backward compatibility as well. So we are safe there. But and this was just an example that if something is not adding value, don't spend time in automating it, and keep E2E tests to minimum. Even though we have a lot of tests, but I don't think we have achieved this. I would like to, but I would still suggest that have less writer end-to-end test and write more tests at the lower level. We haven't found the best place where to write it, or how to do the compromise, but I would recommend it to have less end-to-end test. And this is what the last thing is that, which is very neglected in the QA, next-gen QA world, is manual testing is not required. We can automate everything. Is absolutely not true. Yes, you can automate everything, but then the time and the energy will spend in automating is not worth it. So I would definitely say that manual expert testing definitely adds value. It gives you way faster feedback, some confidence. It should have a lesser impact, but it should still be doing. And you should use tools and computers to do a lot of repetitive tasks, which we have mentioned, where we send notification, where we send reminders, which retries. A lot of things which computer can do, rely on computers to do it, then doing it yourself. And with that, we have time for questions. Sorry.
Yeah, we do have a question. We actually have it's a batch of questions there, so
Perfect.
I hope you have enough time to answer them.
So Ronak, first of all, thank you very much for a very detailed explanation of your process. It's super impressive, guys, what you have achieved, and not just it's a huge way forward in terms of process, but also a huge time and thought investment. So very impressive. Thanks again. We have we have already one question which has 3 questions inside. I have also a few of my questions. So so I think let's start with Katya's question. You can, Ronak, open a Q&A session on your side.
I see them. Let me stop sharing and I'll hold over to you.
Sure.
All right, you are the host now, Nick.
Would you like us to read the question, or you're able to see it?
I can see it. Let me give me 1 minute.
Okay.
All right. So the first question I have is, what processes do you use to make sure the QA team is always aware of plan implemented development changes, especially automation engineer? How often do you find that the test fails and they're not sure if this is regression or intentional change? It's a good question. So we do, the way our automation team understands on new features is they are part of all the epic kickoff meetings. So whenever we introduce a new feature, we used to have a kickoff meeting between a dev, product, and a QA, and we generally try to involve the automation engineers in the team itself. We create a epic ticket for QA as well for related epic which is releasing. So the goal of the QA ticket is to explain, basically write a test plan of how we will test this feature. And we don't want to go in the traditional world of writing test plan in very detailed, but we read in very high level that we are going to automate this scenario. So this features will be automating it. This thing will be tested manually. And this is what we are going to automate based on those features. And for most of the epics, we used to have an integration branch. An integration branch is a branch where more than one devs work against it and keep merging their changes. And the QA writes test against that integration branch itself. So, and when every test is passing on that integration branch, we do manual testing, or we test that feature is working correctly. And we call a feature called a hybrid tester, which that person is responsible to do manual testing as well as write automated tests for it. And if everything looks correct to that tester on that integration branch, we merge that changes, we release that feature to production. So that branch will have, and that person will design what he and she needs to automate and whatnot. We do something called a grooming session for QA as well, where we sit with dev and QA, or sometimes product as well. We add them in to get their input that I mentioned that this is what we are planning to automate from our end-to-end perspective. Where are other tests written? So that dev can explain that I have written unit tests or integration tests for this pieces. This is not tested. And then QA fills those gaps. And that grooming session for 15-20 minutes saves so much of our time that we have a thorough coverage and confidence on that feature that this change is already tested. This is a third-party call, which is no control over. We will not automate it. This is something which is using the third-party charting library, for example. We're just embedding that. We won't automate that because we are just feeding data. So we will only validate the data is correct or not. So all those discussion happens in those conversations. And that's how we know that what we will automate, how we will automate, and who will automate that. And the second part of that question was that how do they find out at least that a test fails if they're not sure if there's regression or intentional change? Since our test runs on every single branch, we know that if this test only fails on this branch, there's something has to wrong on this PR versus what's happening on the master branch. Because if it's running well on master, failing on your feature branch, it means that a new change has caused it, or your test is flakier. So that, and since our test runs on every single PR, the engineer can just go to GitHub, look at the other PRs and see where it failed or where it is failing consistently. So we know it immediately. So they are actually keeping an eye on their PR against the integration branch if it is failing. And we run the test on every single change. So if we push a change, our checks gets running again. So they are generally up to date on what's failing on their particular branch. So we have never seen a scenario where they have questions whether they have it or not. The next question. Sorry, this is so many questions, but good questions though. What are the main points you experience in the area of automation? So the main pain points we have experienced is there are a lot of pain points actually. It's not one answer to that, but a main area of concern is if you're adding a check, is the check legit? I'm not worried about we have enough tools or enough technology to automate. I'm worried about more rational thinking of if this automation makes sense. For example, we add a new style on a Forbes logo. There is no point of automating that change because there is very less likely of breaking that particular styling unless the whole SaaS class changes or something like that. So we don't really need to automate those. So that is one pain point where I'm educating team that don't automate things which don't add value, and only add checks which is really adding value to a test, which will save manual time, which will check. So those are the second pain point. And cross-browser compatibility is obviously another one, where if the newer version of the browser comes in, a test fails, or newer version of Cypress or Protractor or Selenium comes out in our test fail. Those are other pain points which we are facing in day-to-day point. But my main concern is more educational to the team member of what to automate and what not to automate. I think we have enough tools and technologies to overcome most of the scenarios, but the major one is more educational. And the last is how is documentation been maintained in Forbes to up to date? Is there a role responsible to be developer testers? Yeah, so we use TestRail, which we started using last year. Initially, Confluence used to be our source of truth. Now we migrated our test cases to TestRail. So we used to have a bigger manual team, and that team did a good job of migrating all our Confluence test cases into TestRail. And TestRail is our source of truth for adding anything. We don't write step by step for our test cases like this happened, this happened, this happened. We write very high level test case, so it's really it saves time for people. So to answer your question, TestRail is one sort of documentation. The second one is Jira and Google Docs. So all our and Confluence. So all our epics are written, have a features, and then the detailed description we call as a TDD, technical design documentation, for every feature we built on. So technical design documentation is started by the lead engineer for the project. QA adds their part of it, operation adds their part of it. So how the feature is tested, how the feature is built, versus how and where it will deploy. So that will have a technical documentation versus the feature, how feature works. They write it inside a Confluence page or a Google Docs page. And then we embed those Google Docs page inside our Confluence page so that we have everything aligned together. And our Jira will have all the linkage of all three things together. So test documentation on TestRail, product documentation on Google Docs or Confluence. We are all over the place, and then there is a feature technical documentation which we write for each feature in a Google Doc, and we manage that. Yeah.
Great. Thanks, Ronak. I have more questions. Let's just see if there are any other questions here from the audience. I wrote down a few questions here.
Yeah.
I think one of interesting questions for me is, there is a lot of debate how to structure the modern, quality testing team or process, right? And what I heard is very interesting, that kind of on one side, right, your team seems to be really dev oriented, almost like, it's almost like just a regular developer team, right?
Correct.
But still you have some exploratory testers, and it still seems to be separated as a separate unit, right? So what's your take on it? I mean, what you think is the right modern structure, or I would say modern process, in terms of, should it be just as a mixture of developers and testers together? Should it be still as a separated unit? Does it depend on organization or other parameters?
I think in the newer DevOps world or DevOps culture, I would say, it has to be one team. But what have worked really well in my past experience is that it's really good, looks nice on paper that we have a DevOps culture where everyone is responsible to build, everyone is responsible to test, everyone is responsible to deploy. But then when we don't have a clear set of responsibilities, and what really well for us is to have a QA team specifically focused on quality, is that they became a product expert of the feature as well. So for example, our manual testers who are doing exploratory testing, they know the feature inside and out way more than our dev knows, or way more sometimes our product owner knows, or also way more than our automation engineers knows. So their knowledge of the platform it adds tremendous value when they test it as well. First, they have a knack of finding those weird cases, which is really hard quality to get to have every other people a normal person has it, and they can find all those cases, and then which will help developers to fix those, or a QA to find it and automate it, and that adds so much value versus which is harder to such people with so many different skills to do that. Like a developer could be an amazing tester, but then that's not his sole focus. His sole focus is to deliver big features, write a good quality code so you can deliver a better product. He can do the testing, yes, but then what's is more worth it? So that's why it's more cost effective for us to have a dedicated manual testing person, even though we don't need a huge manual team. I would say we have one manual tester per product. So for example, when I'm saying one manual tester, I mean one person who's responsible just to test our front end of our site. We have one person who is responsible to test our entire CMS, which is huge. And our front end is a huge application, all the different types of pages, all the different types of, only one person is responsible for testing it. We have one person to check for API and some of our data products. So we don't have a huge manual tester team, but we have an expert in who checks those and adds so much value, because the number of defects which we are finding or quality of defects which we are finding by that manual testers is tremendous. That we have not found those defects for automation engineer. And and this might be true for very other people might have in this panel might have found it as well, is automation is adding value, but automation always gives you a peace of mind. They are never finding any crucial defect. Like 1 in 6 months, we have found a couple of defects from automation, which has prevented us a potential broad rollback. Because if they find it way earlier as itself. And our QA team, manual team, has found some of those issues, and we're like, oh wow, we should automate that. So I think that manual team is definitely adds value.
Yeah, and I think additional aspect is probably that, you know, in a solely dev-oriented teams, when there is no QA, so there's also no one responsible role, which kind of, you know, makes sure that the quality is there, right?
100%. Yeah, because I've seen requests from devs itself, like they build a new feature, they are worried that if this works correctly or not, they won't have time to QA all those features because they're reviewing other codes, doing other thing. If they have a dedicated manual person who expert of the product, who knows the product inside out, they can just tell them that, can you check around these changes, what will impact? And the idea we introduced our hybrid tester is that person understand both pieces. That person solely focus on testing it, but they also understand the code base. So if they know that, oh, this class is changed, this class is used at 10 different features of our product, this might be affected. Let me check all those if it does correctly or not. So hybrid tester is really, we haven't seen the fruits of it yet, but it's a long process. But those people who understand the code and do the good job on testing, they will be tremendous value down the line when they build both the skills.
Right. Cool. And another question is, you know, you mentioned, at least from slides, it looks like you have tremendous amount of end-to-end testing. And on one side, on the other side, I guess you also have API testing. You know, what's your feeling? I mean, what's the ratio? What is the right ratio? I know you mentioned in one, I think in your last slide, is to minimalize end-to-end testing. On the other side, I think you also mentioned that end-to-end testing gives us more confidence in terms of, you know, this is how actual the end user are going to experience our platform. So what's your take on it? I mean, what's the right proportion, or, you know, are there any hacks, you know, you can use?
I wish there is some. There is none actually. So it's all judgment based as well, as I mentioned before, which is the hardest part in automation, that you don't want to automate everything, but you also don't want to leave everything as well. So it's just the judgment of a tester or a good tester to determine what they really want to automate. For API and the front end end-to-end test. So the reason by doing API solely integration test is they give confidence that we don't have to build front end to test the API change. So if it's breaking the front end, sure, we can check it. But then if we can check at a lower level, that adds more value, because if the API dev is working on a change, it runs all the API integration test, it starts failing, they will know right then deploying a change to environment which front end uses it, then run the front end test. It takes more steps to make it happen. So writing a test at a lower level at API, it adds tremendous value. So our goal is that when we introduce an API change, we write a test there itself, test as a black box from QA perspective. We make it's basically REST API test where we make a request, checks with all the different parameters, and then checks the response is correct or not. And when the front end uses it, we write the test on the front end side, making sure that things which should show up on the front end shows up correctly. And we do leverage API response in our front end test as well. So for example, when I mentioned we use Cypress, what we check there is that we check what response we are getting from API. So we don't hardcore assertion on the front end. We check, what is API giving us? API might give us dynamic data. So based on the response from the API, we capture that and we assert that, getting that on the front end or not. Because Cypress allows you to listen to your request made within your browser. So you can capture that request and check for your response.
Right.
That helps out.
Right. Yeah, I must say, I mean, you guys, I think, working on the edge, very thin line, because I think, most organization today is, either have a lot of manual tests or a lot of automation tests, or have a lot of API tests and a lot of end-to-end tests. It's very rare to see some kind of very, precise or, very, a combination of both. And it looks amazing. I mean, it looks like you found the right proportion that works for you, that combines kind of both worlds.
Yeah. It's kudos to the team as well. They've been really hardworking bunch of folks. I am lucky to get that nice team. But to be honest, last year till July, August, we didn't had zero integration test on our API. So we only used to have unit test on the API. But then writing integration test on API is not hard. It's really simpler. And it's very much stable as well. We can run really fast so many tests. I didn't put numbers of our API tests, but we run close to, I think I have one team member in the call as well. He might know the number, but it's pretty less. It's around like 500 to 600 tests which we write for API, but they run super fast. And we wrote those tests in a matter of 3 months. So, and it was really simpler. So I think adding, and to convey my point is that adding tests at lower level is so much beneficial than writing end-to-end tests. And that's why I say add lower end-to-end tests, because if you have confidence in more API tests, and if your unit test is covering the right thing on the front end, there is no reason to write a thorough end-to-end test, because it's costly, it takes a long time to run. And
Right. And another question is, are there any dashboards? I mean, how you centralize all this? I imagine you have, hundreds of different metrics and data that's flowing from different stages of your continuous testing process. So is there a single dashboard? Is there a single platform? I mean, how's management, how you collaborate with the management decision makers? Is it more verbal? Is it the kind of, oh, here it is, a dashboard, or anything like this?
I wish there was. We don't have that. So you have any dashboard which shows up an overall picture of a release schedule, or how we have all we have is we used to use Hygia. If you're familiar with that one, is an open source, Capital One made it open source tool, a dashboard tool. We integrated that. We didn't use it too much success, but we don't have any. So what we have is Jenkins is our source of truth. So Jenkins pipeline shows up when something got deployed, and Slack is the only place where you can see when all things were deployed, which deployed when and what. But we don't have a centralized, like a diagram will say, or centralized configuration management system. Jenkins is our configuration management system. Jenkins file is where we will configure a pipeline, configure our steps or stages to run it. Or a configuration to talk to browser stack, or configuration to talk to different places, we don't have that place. We do that, all this configuration manually in the code. If there is one place, that would be a dream.
Right. Yeah, because I see many organizations, it's kind of abusing CI/CD tools to kind of also become a reporting tool, which this is not really what they were built for and dedicated for. So I definitely see this problem coming over and over again. And I think we in Cloudbeat kind of trying to bring solution to this problem with our analytical side. So it was interesting to see how you guys, if you have any solution in place. Okay, cool. I think really just last two questions. About keeping up with Selenium. I think you kind of touch it, or going to more progressive or modern frameworks like Cypress, Test Cafe, and there are a few more. I know you mentioned that Cypress has a greater speed and more reliable. I mean, in your setup, it seems that there are no flaky tests, no false positive. Is there such a thing, or you still have flaky tests, and how you handle them?
We still have flaky tests, and that was the reason we rerun them. We rerun them 5 times for Selenium and 3 times for Cypress. Only reason so that a rerun will pass that flaky test and make it passing. And there is flakiness in Cypress as well, and there is flakiness in Selenium as well. It's how the test is written, and it's how our application is responding, and the browser and the internet, and it's all the other messiness. And that's the reason we don't have to. You should have lesser E2E tests, And that was the only reason where you shouldn't have many ETV tests.
Right.
But you need to, because then that will give you more confidence that it's working
Right.
correctly. So yeah, so there is no perfect answer. I would say yes, it is still not great. We still have a flaky test if the test is not written correctly. And then there are bugs on Cypress side as well. There are bugs on the Selenium side as well.
Right.
Only advantage of Selenium is a huge community of Selenium have. You can get answers from other people you are stuck at. Cypress has a growing community, but then they have a good development cycle as well, where their feature requests are getting chugged along
Right.
pretty well or faster. So we can get those features built in, and it's free tool for our case. 5 years down the line, who knows what it would be? We might
Yeah.
hesitate. So
It's true.
for now, we are using what they have.
And say you have a failed test, right? How you take it further? I mean, is there a manual tester who takes a look at this failed test? Is there any automated, I don't know, quality gateway mechanism or anything like this? And how much time you spend analyzing your tests?
So a quality mechanism is that if the pull request fails in a test, the dev notifies a QA that a test is failing if they can't figure out what is really wrong. Sometimes a QA sees that the test is failing constantly on this PR. They takes a look at what's actually failing. Our manual, very brute force effect is we manage a spreadsheet of all our flaky tests and start adding items to it and create tickets in our backlog to work on to fix a flaky test. Like for example, we have a ticket in our queue where we want to fix like 5 different flaky tests, which runs 5 times and passes 1. So we identify those tests, and then like Protractor don't have like, or Selenium don't have a built-in way of rerunning the flaky test or rerunning the failing test. So we, in our hacky way is that we capture the response from the test report, then grab the spec file and rerun the spec file again until it passes. So the only bad part of Protractor doing that, we have to rerun the whole spec file if one of the tests in a spec file failed. So a spec file needs to be smaller as well. We have to rerun the whole thing. It will take a long time. Cypress helps us out that you can only run that particular test which failed. So it saves time, and the execution time reduces significantly.
Right.
So yeah, so our mechanism of notifying is GitHub PR. We don't want to, and we can add a Slack hook and send a message to Slack, but then it will too much noise. So if one branch or one PR pull request needs to release to production, we just look at the checks on that pull request. If it fails, release it. If it doesn't, if it passes, release it. If it fails, push it back. So it's most like shift left approach.
Right. Okay, amazing. Okay, I think, just the last one, and I think we are good, probably, unless let's see if we have more questions. I don't think so.
We don't have any more.
Okay, what's your take on visual testing? I don't think you mentioned any. Do you think it's,
Yeah, it's on my wish list to do it in the end of this year. So we are exploring some options like Percy, and other is Apply tools.
Right.
So a couple of tools we are exploring, which will fit in our budget as well as which will add value to our test. So those are a couple of factors we're looking into. So we do have need for adding some sort of visual test because our front end of our site is very visual. So like we can check if the ad is loading correctly or we are making proper requests to serve an ad on the page, but we cannot check really the ad is actually loaded on the page or not. And then if the viewability is done or not. So only way we are finding those issues now, if a revenue number drops or we see a revenue team comes up screaming that, oh, why in 1 hour we are not made any money. So that's the only way we find out. So we need to have a better way. So visual testing is something which is in our pipeline to implement. And we have a Spike ticket in our queue to work on to implement that. But yes, and there are some challenges there as well, but we haven't explored that avenue yet. But I think that is a good tool a QA should have in their armor. It might add value in some cases, not all the cases, but it might add value when you want to check styling specific changes.
Yeah, right. Yeah, it might cover, like you mentioned, the case of logo styling and stuff like this, which, you definitely don't need to add it as your, primary test automation, assertion point.
Correct.
Perfect. Okay, Ronak, thank you so much. I think we pushed it to the limit much beyond we originally planned. But again, I think you're one of the most amazing QA directors that I ever interviewed, and really amazing process and amazing, progress, guys, you did in Forbes. So well done. I think many of our viewers will be interested to hear it. It's a recorded session, so I believe many of those who didn't have an opportunity to join us will listen it. I think also Q&A session was very helpful. I think you elaborated on a few more fields that you didn't have an opportunity to elaborate in your presentation. So thank you again very much. I think just to make this session interactive, let me suggest perhaps we will post this video on our YouTube channel, and so more people perhaps can ask their questions, comment, and we might just ask you to take a look at those comments. So guys, whoever's seeing us like post session, just a recording, feel free just to ask your questions in our YouTube comments, and Ronak will answer them later on. And also, Ronak, I'm wearing here, our Selenium Hero T-shirt. So, this funny bunny. So if anyone wants to get this T-shirt, just guys, Ronak, once people ask questions on our YouTube channel, I will give you a privilege to select the most interesting question, also including the one here. And we will ship this T-shirt to you. I guess after your talk about Cypress, I probably need to do another one with Cypress Hero. So we'll make sure to add this one to the band. And guys, thanks again having you guys. Take a look again on our YouTube channel, Cloudbit, Lucas Cloudbit YouTube channel. We have, of course, Ronak recordings there and our previous webinars. We want to keep conversation going. We are all in the same field, so we want to, to share knowledge, to collaborate, and definitely take a look on. Also, we have very interesting forum, Oxygen forum. Oxygen is our open source project for testing framework based on Selenium and WebDriver IO. So you can also chat with us there and ask any technical questions. We are also preparing some Cypress examples. It's definitely one of most interesting test automation engines we got recently. So let's conversation open, visit our website, and meet you then on next webinar. Thanks again, Ronak.
One thing I would also add is that if you guys, if you have any questions, anything outside this, we can definitely chat on YouTube, but connect on LinkedIn as well, and feel free to reach out to me, and I can answer if I can help you out in any way, shape, or form. Feel free to ask.
Sure. We might just add later on the slide with your contact details if you like, and so you can share your Twitter handle, LinkedIn, all the contact details. So definitely, guys, approach Ronak. As you saw, he led Forbes team to some amazing achievements. So I think it's a great opportunity just to get his experience, his expertise, and help you out in whatever field you need. So thanks again, Ronak. Keep safe in this kind of shaky time, and thanks again for your time and sharing your story with us. Take care.
Thank you, guys.
And yeah, we'll meet you on the next webinars. Bye bye.